Assalamu alaikum students. Today's lecture is about minterms, maxterms, and their forms, sum of product and product of sums. Now what is minterm? Minterms are called products because they are logical and of a set of variables, and maxterms are called the sums, combination of sums, because they are the logical or of a set of variables. Both are exactly opposite of each other. So any Boolean expression can be represented using this minterm and maxterm. Now this is a table related to uh, two variable minterm. Here we have one variable x, another is y. We have four combinations 0, 0, 0, 1, 1, 0 and 1, and their respective minterms will be 0 will be represented as x complement, and 1 will be represented as, for the case of y, it will be y without complement. Here 0, 0, it will be x complement y complement, 0, 1 x complement y, 1, 0 x y complement, and for 1, 1 it will be x y. So x complement y complement will be represented as the m naught, and in the same way x y will be represented as m3. So this is the table representing the max terms. Here we have opposite scenario. For the case of 0 we will represent without complement, and for the case of 1 we will represent with complement. Like if you look at here, for 0, 0 it will be x plus y. For 0, 1 it will be x plus y complement. X is representing 0 and y complement is representing 1. And for 1, 0 it will be x complement y, and for 1, 1 it will be x complement plus y complement, that is m3. Now here is a problem related to conversion. Now let's say f of xy is equal to x complement. So here second variable y is missing, so we will write y plus y complement. As you know that y plus y complement is equal to 1, so you will place y plus y complement with a multiplication operator. So two terms you can derive from here, that is x complement y plus x complement y complement. Now you can see from the table that x complement y complement represents m naught, and x complement dot y represents m1. So in summarized form of minterms you can write it as summation, in bracket you will place minterm number, that is 0 and 1. Now the output of related to this for maxterm must be 2, 3, because if you look at the table, just look at the table that for maxterms. Now x complement dot y complement, you need to find the maxterm for this combination with plus sign. So x complement plus y complement must be here. So x complement plus y complement is m3, and the second variable, that is x complement dot y. So you need to find for maxterm x complement plus y. So here if you look at here, then you will find x complement plus y, that is m2. So you will write the maxterms with the sign of maxterm and variables 2, 3. So maxterms are normally in multiplication form. In this way you can describe here m2 dot m3 with respect to these max terms, that is equal to x complement plus y dot x complement plus y complement. Here z should not be here. I will remove it while uploading the lecture. This is the truth table that is representing the values related to minterms and maxterms. Here you can see that x complement xy, x complement y complement, x complement dot y complement, x complement dot y. Now minterms are here according to our question, that is x complement dot y complement plus x complement dot y. If you add both of them, then you will find 1100, and after that if you get x complement plus y and x complement plus y complement according to the next term and then multiply both variables, then you will find this 1100. Both are same, but the representations must be different. Here the zeros will be considered as max terms because it is exactly opposite of min term. So you have min term 0 1 and you will have max term 2 3. So original expression is SOP. SOP stands for a sum of products, and POS, that is product of sums. So min term is sum of products and max term is product of sums. So both are equal, and you have already proved in truth table earlier here. Now canonical form. It is easy to represent larger expressions by using minterms and maxterm notation. For example, we can write f of xy is equal to x complement dot y complement plus x dot y complement simply as summation of 0 and 2. And in the form of next term, just memorize the previous question. You have converted this this combination to this form, that is x complement plus y complement dot x plus y complement. So it will be m1 and it will be m3. So if you look at here, you have opposite combination. For two variables you have four combinations, 0 1 2 3. If 0 and 2 is in min term, then obviously you will have 1 and 3 in the max term. Now you need to find the canonical form for this expression. So do it yourself and share with me in Google Classroom. Now in terms of three variables, we have three variables x, y, z. So as you know that 0 is represented with complement and 1 is represented for 1 1 1. You can see here for 1 is represented without complement. So for three variables you will have min terms from m0 to m7, and max terms are opposite. 0 is represented with without complement variable and 1 is represented with complemented variable. So in the same way you will have max terms from m0 to m7. Now min term and max term for three variable. Here you can see the comparison between min terms and max terms. These are the min terms 0 to 7 and these are the max term. As you look at here, these are completely opposite of each other. Here m5 is x dot y complement dot z and max term m5 is x complement plus y plus z complement. So just you need to apply the De Morgan law. You will find out the max term value. So this table is also representing the representations of min terms and max terms. For the four variables, let's say we have w, x, y, z. We can place w here too, w, x, y, z. So you will get min terms in this way and max terms in this way. So there will be m0 to m15. 15th minterm is not visible here, you can look at your lecture. Now conversion of max term into minterm and vice versa. Now you need to apply De Morgan's law. For example, m0, it is minterm x complement dot y complement dot z complement. Now it's, if we apply De Morgan's law here, then m dot complement is equal to x complement dot y complement dot z complement, the whole complement. So you know, if you apply complement, then the variables with the complement will be after applying complement will be without complement, and multiplication operator will be replaced with addition operator. So you will get x plus y plus z, that is m naught for the case of max term. Now if we have max term m5 x complement plus y plus z complement, if we take if we apply De Morgan law here, then we will place complement outside this. So x complement plus y plus z complement whole complement is equal to, now you will get, if we apply complement inside, then x complement will be replaced with x and plus will be replaced with multiplication operator. Y will be replaced with y complement, and again plus is replaced with multiplication operator. Then z complement is replaced with z. So if you look at the table, then you will get minterm m5. So this is an example related to 4 variables. For the case of m9 minterm, you know, it is sum of products. So it is a single term representing product, that is x complement plus y plus z plus, sorry, x complement dot y dot z dot w complement. Now you just need to apply the De Morgan's law here, place complement here, and x complement is replaced with x, dot will be replaced with plus, y will be replaced with y complement, again dot will be represented with plus, z will be replaced with z complement, and again this dot will be replaced with plus, and w complement will be replaced with w. And now if you look at your table, you will get m9. Now advantages, two basic advantages of minterm and max terms: writing any boolean expression in canonical form, and writing boolean expressions in sum of product or product of sum forms. So easy to represent large expressions by using minterm and max terms. For example, we can write this expression x plus x complement plus y x complement dot y complement dot z complement plus x dot y complement z complement in the form of minterms as m0 plus m4, that is sum of products. In the same way, for representation of max terms, you can write this larger term as this term will be replaced with m5, and this term will be replaced with m3. So you need to convert these expressions into their respective canonical form in your assignment. Now SOP, sum of product and product of sum form. The minterms are also called sum of products, where max terms are called product of sums. So these are examples related to minterm and max terms. So this term, which we earlier discussed, is sum of product form, and this form is called product of sums. So you can write min terms and max terms of following Boolean expressions. But here the issue is z, for the case of um, for this case, if you look here, then you will realize that here z is missing. If you look here, you will realize x is missing. In the same way, you will realize here that z is missing, and here again x is missing. So you cannot convert it into respective minterm or maxterm, because it represents minterm or maxterm of three variables. So in order to solve this problem, you need to look at missing variable and apply the rule of Boolean expression, that is, for example, a plus a complement is equal to 1. Now for case of this problem, you will find here that z is missing, then you will multiply it with z plus z complement. Here x is missing, so you will multiply it with x plus x complement. After their combination, multiplication, you will find these four combinations: x complement yz, x complement yz complement, x complement zx plus y complement zx complement. So it's better to arrange them in an order x, y, z. So you will find this expression. After converting into minterms, you can look at your minterm table. You will get m3, m2, m5 and m1. Just arrange them in an order: m1, m2, m3 and m5. Then after that, you will get max terms. You know, max terms are opposite of min terms. Then obviously the missing numbers will be placed in max terms. So here 0 is missing, m0. Here 1 2 3 4 4 6 and 7 are missing, so you will place m0 dot m4 dot m6 dot m7, and you can place the combination behind these max terms here and write them in the form of product of sums. So in the end you get min terms 1 2 3 5 and max terms are 0 4 6 and 7. You can use truth tables to verify that both present same value. So by writing this truth table, you just need to apply the combinations and write the results here. Just like if you can look at here, then m0, this represents m0, then m0 is 0, but this represents m1. Here you have m1, so you will place 1 here. 2 is missing, no. Hmm. Okay. 0 1 2 3 . m not dot import. Okay, you just need to derive the whole table. Here it's a bit confusing. Just need to write the combinations for m1, m2, m3 and m5 and then add them simultaneously. You will find this column, and then again you need to place ones for m0, m4, m6 and m7, then multiply all the terms, you will get this column. Okay, so you must verify this, and then you will you will have to give me feedback that the combination is right or wrong. Now here is a question: x plus y complement dot y plus z complement you need to represent into sum of product and product of sums form. So again you will look for missing terms. Like you will have for first step you need to get the missing variable, that is z. For first case it is z, so you will have xy xz, so you just need to multiply them, xy and xz complement plus y complement will be 0 and y complement z complement. So in next step you will look for missing variables. For xy z is missing, for xz complement y is missing, for y complement z complement x is missing. So you will place z plus z complement here, y plus y complement here and x plus x complement here. Now multiply them, you will get the minterms 0, 1, 4, 5, 6 and 7. Now it's the missing terms left are only 2 and 3. So 2 and 3 will be your max terms, that is x plus y complement plus z multiplied by x plus y complement z complement. So in this way you will get the max term 2, 3. So you can convert product of sums into sum of product by applying the De Morgan's law. So these are the practice problems. You need to solve them, and I will be looking for your feedback. That's all for today's lecture.